has a map of the region and calculates the area of the region on paper to be 180 square centimeters. The scale on the map shows that 1 centimeter is equal to 20 feet. So they're giving us linear centimeters to linear feet, not square centimeters to square feet. So I think we're going to have to figure that out. If Erica plans to cover every 400 square feet with 1 pound of seed, approximately how many pounds of seed will she need to cover the entire field? So what we want to do is we want to figure out, well, how many square feet is the field? How many square feet is the field? And we know on her map has a map of the field, and she's on the map, it's 180.
No one knows your listening habits better than you. With Spotify Premium, you can download and pull up your playlists anywhere. Take advantage of offline listening and let your playlists take over, one song at a time. Get 1 month of Spotify Premium free. Tap the banner to learn more.
180 square centimeters, and they tell us that 1 centimeter is equal to 20 feet. But if this is square centimeters, then we want to convert this to square feet. So if 1 centimeter is equal to 20 feet, if we want to figure out the conversion from square centimeters to square feet, we could just square both sides of this. And what will that be? 1 squared is still 1, but now we have 1 centimeter squared. And I can write it like this just to be clear. That's both of them to the second power, but 1 squared is just 1. And this is going to be equal to 20 squared is going to be 400 square feet. So 1 square centimeter on this map is going to be equal to 400 square feet. So how many square feet does 180 square centimeters represent? So I could write 180 centimeter squared. And we know that every centimeter squared represents 400 feet, or we say 400 feet squared per centimeter squared. And we want the units to cancel out, so this makes sense. You have centimeter squared over centimeter squared. So the actual field is going to be 180 times 400 square feet. And that makes sense. The region on paper was 180 square centimeters. Each square centimeter is equal to 400 square feet in reality. So for each of those square centimeters, it's going to be 400 square feet. So it's 180 times 400. So this is the area in square footage of the actual field. And then they tell us we're going to use 1 pound of seed, for every 400 square feet. So let's see, the area of the entire field, we can have a little bit more space, is, I'm not going to multiply it out because this 400 is showing up, so this seems useful. So the area is 400 feet squared times 400. And we're going to use 1 pound of seed for every. Then we have 400 divided by 180. I would be careful because this one is it can be a little bit confusing. You might say, okay, there's 180, which is that choice right over there. Now, if you're under time pressure on the SAT, I would be careful because this one is it can be a little bit confusing. You might say, okay, there's 180 square centimeters. Each of those square centimeters is 400 feet. This is actually the key thing that you have to realize, that not each square centimeter is not just 20 feet, it's 400. It's 400 feet. So you're going to have 180 times 400 square feet for the entire field. But then each of those 400 square feet, you're going to use 1 pound of seed. So you're going to use 180 pounds of seed. So you could have done it without all this writing, but it is helpful to write it so that you don't confuse things.
need something to keep the peace? The Spotify Premium Family Plan gives everyone under the same roof equal listening freedom with separate accounts. Each person can enjoy the premium perks of offline and ad-free music listening from anywhere. Plus, explore music recommendations tailored to your tastes. Tap the banner to learn more.
A local hospital recently conducted a blood drive where they collected a total of 80 pints of blood from donors. The hospital was hoping to collect a total of 8 gallons of blood. From the drive. Did they meet their goal? How much more or less than their goal did the hospital collect? So really, they collected 80 pints. We just need to figure out how many gallons that is, and then say, well, is that going to be more or less than 8 gallons? So we start with 80 pints, and we can take it step by step. You may or may not know how many pints there are per gallon, so let's just go straight to quarts first, and then from quarts we can go to gallons. But if you know right from the, and we can take it step by step. You may or may not know how many pints there are per gallon, so let's just go straight to quarts first, and then from quarts we can go to gallons. But if you know right from the get-go how many pints there are per gallon, you can go there. So let's convert this to quarts. So we have 80 pints. So what are we going to multiply or divide by to get quarts? Well, one way to think about it, you're going from a smaller unit, pints.
Get peace of mind knowing what's coming next when you're listening. Turn off shuffle to tune into playlists and albums from start to finish, all while enjoying uninterrupted music listening. Discover more ways to stay in your zone with Spotify Premium. Tap the banner to learn more.
A local hospital recently conducted a blood drive where they collected a total of 80 pints of blood from donors. The hospital was hoping to collect a total of 8 gallons of blood from the drive. Did they meet their goal? How much more or less than their goal did the hospital collect? So really, they collected 80 pints. We just need to figure out how many gallons that is and then say, well, is that going to be more or less than 8 gallons? So we start with 80 pints. And we can take it step by step. You may or may not know how many pints there are per gallon. So let's just go straight to quarts first, and then from quarts, multiply or divide by together when it goes in by 2 pints. Or you can use this 2 pints per quart or 1/2 of a quart per pint. Either way, the units work out. If you don't have paper, you don't have space to make sure that the units cancel out in this way. So that you know, okay, 140 quarts. And now we can convert this into gallons. We know that there are 4 quarts per gallon, or that 1 gallon has 4 quarts. And once again, we're going to go from a smaller unit to a larger unit, gallons, because we care about times 1/2, and the units left are gallons. 8 gallons. Their goal was only 8 gallons. So did they meet their goal? Yes, they met their goal. How much more or less than their goal did the hospital collect? Well, their goal was 8. They collected 10. They collected 2 extra gallons. Did they meet their goal? Yes, they met their goal. How much more or less than their goal did the hospital collect? Well, their goal was 8. They collected 10. They collected 2 extra gallons. 2 extra gallons than their goal.
However you like to listen, there's a premium plan made for you. Add up to 6 accounts with the family plan to share the love with people under the same roof. Join the Duo plan or go solo with the individual plan and get a discount as a student while enjoying offline and ad-free music listening. Get 1 free month of premium. Tap the banner to learn more. We all move to the beat of our playlists a little differently. And with millions of songs to discover on Spotify Premium, it's good to know you can listen without hearing ads. Just queue up your songs and get in your zone. Get 1 month of Spotify Premium free. Tap the banner to learn more.
A high school class is measuring the amount of nitrate in a local stream. To be considered safe to drink, the maximum amount of nitrate that can be present in water is 10 milligrams per liter. The class takes a sample of 15 liters of water. If the number of milligrams per liter of nitrate in the stream water is 3/4 of the maximum, that is safe to drink. How many milligrams of nitrate should the class expect to find? Is 10 milligrams per liter. So what the class finds, so the maximum that times 3/4, which is going to be equal to what? The way I think about this. So this is a 15 liters of water. Milligram 575. So you expect they would expect to find 112.5 milligrams. There we go. A high school In order to connect to the internet, dedicated computers are kept in a server room. To prevent overheating, the density of computers in a server room must not exceed 2.1 computers per cubic. Computers are kept in a server room. To prevent overheating, the density of computers in a server room must be 3.28 times 3.28 times feet. And something larger than 20, I would pick. Now, if you had a lot of time, you could multiply density in cubic feet. So time 8 to the third power feet Q8 times 3, thing like this. So if you could put 2.1 computers per cubic foot, if you could put 2.1 computers in this small cubic foot right over here, surely you're going to be able to put a lot more than 2.1 computers in the cubic meter. And just off of that, you can rule out these two choices because these two are less than 2.1. But how would you actually put a lot more than 2.1? So if you could put 2.1 computers per cubic foot, if you could put 2.1 computers in this small cubic foot right over here, surely you're going to be able to put a lot more than 2.1 computers in the cubic meter. And just off of that, you can rule out these two choices because these two are less than 2.1. But how would you actually calculate it? Well, you can just multiply this volume, a cubic meter. You can to figure out how many cubic feet it is, you can just multiply by the dimensions in terms of feet. So this right here is going to be 3.28 feet in that dimension. It's going to be 3.28 feet high, and it's going to be 3.28 feet, if you call this dimension maybe deep. And so what's the volume right over here? Well, it's going to be 3.28 times 3.28 times 3.28. So the volume here is 3.28 to the third power feet cubed, cubic feet. And this is how many cubic feet you have per cubic meter, because this whole thing is also a cubic meter. Times feet divided by cubic feet. And if you multiply, you're going to get 3.28 to the third power times 2.1. That's this times this. Computers computers per meter solve it some way, but we can estimate because these two remaining choices are quite different. What's 3.28 to the third power going to be roughly? Well, 3 to the third power is 27, so this thing is going to be larger than 27. And if you multiply something larger than 27, well, these numbers look right. The 3.28 to the third power times 2.1 actually would be just deduced. Pick if you forgot to convert to cubic, if you forgot to convert how many cubic. This is kind of an answer to pick. If you forgot to convert to cubic, if you forgot to convert how many cubic feet are per cubic meter, and if you just kept things in linear meters and feet. Because then you might say, okay, if I have 2.1 computers per cubic foot, and if you just say, oh, I'll have 3.28 as many feet per meter, not thinking in terms of cubic feet and cubic meters, but if you take 2.1 times 3.28, that's probably this choice here. I haven't multiplied it out, but that looks like 6.89. So that's where this answer actually came from.
however you like to listen, there's a premium plan made for you. Add up to 6 accounts with the family plan to share the love with people under the same roof. Join the duo plan or go solo with the individual plan and get a discount as a student while enjoying offline and ad-free music listening. Get 1 free month of premium. Tap the banner to learn more.
I go to the fruit store today. They have a sale on guavas. Everything is 30% off. This is for guavas. On guavas. And it's only today. Only today. So I say, you know what? Let me go buy a bunch of guavas. So I go and I buy 6 guavas. So I buy 6 guavas. And it ends up when I go to the register, and we're assuming no tax for, it's a grocery in the state where they don't tax groceries. So for the 6 guavas, they charge me, I get the 30% off. They charge me $12.60. $12.60. So this is the 30% off sale price on 6 guavas. So we have the full, the full 2. Imagine there's a X with this step, but you can use 0 goes into the 0.7, 2 straight up, and it's 7, 6 equal to 6. That's full price divided by 6 is $3. 2 guavas, so $15. 2 is $12.60. Price of 6 guavas is equal to $12.60, and that's equivalent to saying 70% of the full price. Is $12.60. We solve this algebraically, divide both sides by 0.7, and then we got X, the full price of 6 guavas, is $18, or that's $3 per guava, or $6 for 2. Anyway, hopefully you found that helpful. Full price of 6 guavas is
Take the guilt out of your listening pleasures by indulging in what you love with Premium. Download and listen to ad-free music wherever your day takes you, so it's even easier to tune in to what you really want to hear. Get 1 month of Spotify Premium free. Tap the banner to learn more.
We're told today Ibuka opened a new cereal box. He ate a bowl of the cereal, which was 8% of the cereal in the entire box. Approximately how many more bowls of cereal can Ibuka expect to get? From this box. So your original box, then every serving he eats 8, and so he's left with 92, and if every serving he's eating 8, 92 divided by 8 is 11.5. Right over here. Now we have 92% of the higher box. Approximately how many more bowls of cereal can Ibuka expect to get from this box if he continues to eat the same amount of cereal in each bowl? All right, pause this video and see if you can answer this on your own. There's several ways that you could approach this. You could say, all right, the box starts off with 100% of the cereal. Then in that first bowl, he eats 8%, and so you're left with 92% of the original new box amount of cereal, and then every time he's going to eat 8% of the original amount that was in the box. So if now we have 92% of the original amount of the box, and at every serving he's going to eat 8% of it, we just divide by 8% to figure out how many servings he'd have. And so 92 divided by 8, see 8 times 11 is 88, and then you have 4 more, so this is going to be 11 and a half bowls, and that is this choice right over here. If the percent is confusing, you could say, all right, let's just imagine that there were, I don't know, 100, pick a unit in the original box, then every serving he eats 8, and so he's left with 92, and if every serving he's eating 8, 92 divided by 8 is 11.5. A pair of jeans that regularly cost 40
Just like you, what you listen to evolves over time. Experience a whole new world of listening without hearing ads on Spotify Premium. It's just you and the music that helps keep you going. Get 1 month of Spotify Premium free. Tap the banner to learn more.
$30 is on sale for 30% off. As part of a promotion, each customer will also receive an additional discount on the marked sale price at the cash register. If the final price of the jeans was $22.40, what additional discount was applied to the marked sale price? All right, this is interesting and useful because we need to know what we're going to pay for our jeans. All right, so the regular price is $40. We're going to assume everything is in dollars. It's on sale for 30% off. Well, if you're 30% off, that means it's going to cost 70% of the regular price. So let's put 70% of 40. So let's multiply that times 0.7, which is the same thing as 70%. 40 times 0.7, that's going to be equal to $28. Right? Yeah, 7 times 4 is 28. 0.7 times 40 is also going to be $28. All right, so it's going to be $28 would just be the 30% off. But the final price of jeans was $22.40. What additional discount was applied to the marked sale price? Well, to figure that out, we can just divide. We can say, well, what fraction of 28 is $22.40? $22.40 divided by 28. Well, this is going to be equal to, let's see, 28. Actually, you could even rule out. Well, I'll do the arithmetic right over here. So sale price. Well, to figure that out, we can just divide. We can say, well, what fraction of 28 is $22.40? 27 times 40 is also going to be 28. All right, so it's going to be $28 would just be the 30% off. But the final price of jeans was $22.40. What additional discount was applied to the marked sale price? Well, to figure that out, we can just divide. We can say, well, what fraction of 28 is $22.40? $22.40 divided by 28. Well, this is going to be equal to, let's see, 28. Actually, you could even rule out. Well, I'll do the arithmetic right over here. So 28 goes into 22 times this 20 times. So we can make 14 goes 6, 80%. Because once you take 20%, then you're going to pay 80% of the price. Percent of that. So they took off another 20%. They took off another 20%. If you take off 20%, then you're going to pay 80% of the price. 80% of that, and the are down.
Hello guys, I hope you are doing really well. First of all, if you also to do, we have to divide this 20, okay, this 20%, okay, it with cost price 100. The next step, we have to simply put the formula to calculate the selling price or ST. So the formula is cost price plus this markup.
price. So if this is 80%, if this is 80% of this, then the additional discount that was taken is going to be 20%, because once you take 30% off, you'd expect to pay $28, but you only paid 80% of that, so they took off another 20%. They took off another 20%. If you take off 20%, then you're going to pay 80% of the price.
number you have dialed is not available at present. Please leave your message after the beep.
Need something to keep the peace? The Spotify Premium Family Plan gives everyone under the same roof equal listening freedom with separate accounts. Each person can enjoy the premium perks of offline and ad-free music listening from anywhere. Plus, explore music recommendations tailored to your tastes. Tap the banner to learn more.
We will now begin our journey into the world of statistics, which is really a way to understand or get our head around data. So statistics is all about data. And as we begin our journey to the world of statistics, we will be doing a lot of what we can call descriptive statistics. So if we have a bunch of data, and if we want to tell something about all of that data without giving them all of the data, can we somehow describe it with a smaller set of numbers? So that's what we're going to focus on. And then once we build our toolkit on descriptive statistics, then we can start to make inferences about that data, start to make conclusions, start to make judgments, and we'll start to do a lot of inferential statistics, make inferences. So with that out of the way, let's think about how we can describe data. So let's say we have a set of numbers. We somehow describe it with a small, all about data. And as we begin our journey to the world of statistics, we will be doing a lot of what we can call descriptive statistics. So if we have a bunch of data, and if we want to tell something about all of that data without giving them all of the data, can we somehow describe it with a smaller set of numbers? So that's what we're going to focus on. And then once we build our toolkit on descriptive statistics, then we can start to make inferences about that data, start to make conclusions, start to make judgments, and we'll start to do a lot of inferential statistics, make inferences. So with that out of the way, let's think about how we can describe data. So let's say we have a set of numbers. We can consider this to be data. Maybe we're measuring the heights of our plants in our garden. And let's say we have 6 plants and the heights are 4 inches, 3 inches, 1 inch, 6 inches, and another one's 1 inch, and another one's 7 inches. And let's say someone just said in another room, not looking at your plants, just said, well, you know, how tall are your plants? And they only want to hear one number. They want to have one number that represents all of these different heights of plants. How would you do that? Well, you'd say, well, how can I find something that maybe I want a typical number? Maybe I want some number that somehow represents the middle. Maybe I want the most frequent number. Maybe I want the number that somehow represents the center of all of these numbers. And if you said any of those things, you would actually have done the same things that the people who first came up with descriptive statistics said. They said, well, how can we do it? And we'll start by thinking of the idea of average. And in everyday terminology, average has a very particular meaning. As we'll see, when many people talk about average, they're talking about the arithmetic mean, which we'll see shortly. But when in statistics, average means something more general. It really means give me a typical, or give me a middle number, or these are ors. And really, it's an attempt to find a measure of central tendency. Central tendency. So once again, you have a bunch of numbers. You're somehow trying to represent these with one number. We'll call it the average. That's somehow typical or a middle or the center somehow of these numbers. And as we'll see, there's many types of averages. The first is the one that you're probably most familiar with. It's the one that people talk about, hey, the average on this exam, or the average height. And that's the arithmetic mean. So let me write it in. I'll write it in yellow. Arithmetic mean. When arithmetic is a noun, we call it arithmetic. When it's an adjective like this, we call it arithmetic. Arithmetic mean. And this is really just the sum of all the numbers divided by arithmetic. When it's an adjective like arithmetic mean. When arithmetic is a noun, we call it arithmetic. When it's an adjective like this, we call it arithmetic. arithmetic mean. When arithmetic is a noun, we call it arithmetic. When it's an adjective like this, we call it arithmetic mean. And this is really just the sum of all the numbers divided by, this is a human constructed definition that we've found useful, the sum of all these numbers divided by the number of numbers we have. So given that, what is the arithmetic mean of this data set? Well, let's just compute it. It's going to be 4 plus 3 plus 1 plus 6 plus 1 plus 7 over 1 is 8, and we have 7, or 4.6. No one ever computation found useful. The middle numbers. Let's try to figure it out. Let's try this. I reordered this. So we have 1, then that is your median. And the median is literally looking for the middle number. So if you were to order all the numbers in your set and find the middle one, then that is your median. So given that, what's the median of this set of numbers going to be? Let's try to figure it out. Let's try to order it. So we have 1, then we have another 1, then we have a 3, then we have a 4, a 6, and a 7. So all I did is I reordered this. And so what's the middle number? Well, you look here, since we have an even number of numbers, we have 6 numbers. There's not one middle number. You actually have 2 middle numbers here. You have 2 middle numbers right over here. You have the 3 and the 4. And in this case, when you have 2 middle numbers, you actually go halfway between these two numbers. You're essentially taking the arithmetic mean of these two numbers to find the median. So the median is going to be halfway between 3 and 4, which is going to be 3.5. So the median in this case is 3.5. So if you have an even number of numbers, the median are the middle two. Essentially the arithmetic mean of the middle two, or halfway between the middle two. If you have an odd number of numbers, it's a little bit easier to compute. And just so that we see that, let me give you another data set. Let's say our data set, I don't know. But in this is that is greater than, and see, this is the one that's probably used least often in life, is the mode. People often forget about it. It sounds like something very complex. But what we'll see is it's actually a very straightforward idea. And in some ways, it is the most basic idea. So the mode is actually the most common number in a data set. If there is a most common number, if all the numbers are represented equally, if there's no one single most common number, then you have no mode. But given that definition of the mode, what is the single most common number in our original data set, in this data set right over here? Well, we only have 1 4, we only have 1 3, but we have 2 1s. We have 1 6 and 1 7. So the number that shows up the most number of times here is our 1. So the mode, the most typical number, the most common number here is a 1. So you see, these are all different ways of trying to get at a typical or middle or central tendency, but you do it in very, very different ways. And as we study more and more statistics, we'll see that they're good for different things. This is used very frequently. The median is really good if you have some kind of crazy number out here that could have otherwise skewed the arithmetic mean. The mode could also be useful in situations like that, especially if you do have one number that's showing up a lot more frequently. Anyway, I'll leave you there, and the next 2 videos, we will explore statistics even deeper. In the last video, we talked about different ways to represent the central tendency or the average of a data set. What we're going to do in this video is to expand that a little bit to understand how spread apart the data is as well. So let's just think about this a little bit. Let's say I have negative 10, 0, 10, 20, and 30. Let's say that's one data set right there. And let's say the other data set is 8, 9, 10, 11, and 12. Now, in both, let's calculate the arithmetic mean for both of these data sets. So let's calculate the mean. And when you go further on in statistics, you're going to understand the difference between a population and a sample. We're assuming that this is the entire population of our data. This is the entire population of our data. So we're going to be dealing with the population mean. We're going to be dealing with, as you see, the population measures of dispersion. Now, these are all fancy words. In the future, you're not going to have all of it. You're just going to have some samples of it. You're going to try to estimate things for the entire population. So I don't want you to worry too much about that just now, but if you are going to go further in statistics, I just want to make that clarification. Now, the population mean, or the arithmetic mean of this data set right here, it is negative 10 plus 0 plus 10 plus 20 plus 30 over, we have 5 data points over 5. What is this equal to? That negative 10 cancels out with that 10. 20 plus 30 is 50 divided by 5. It's equal to 10. Now, what's the mean of this data set? 8 plus 9 plus 10 plus 11 plus 12. All of that over 5. And the way we can think about it, 8 plus 12 is 20. 9 plus 11 is another 20, so that's 40, and then we have a 50 there. Got another 10. So this is once again going to be 50 over 5. So this has the exact same sample. Well, no, it's going to be very close. They have the exact same population means, or if you don't want to worry about the word population or sample and all of that, they have both of these data sets have the exact same arithmetic mean. When you average all these numbers and divide by 5, or when you take the sum of these numbers divide by 5, you get 10. Some of these numbers divide by 5, you get 10 as well. But clearly, these sets of numbers are different. You know, if you just look at this number, say, oh, maybe these sets are very similar to each other. But when you look at these two data sets, one thing might pop out at you. All of these numbers are very close to 10. I mean, the furthest number here is 2 away from 10. 12 is only 2 away from 10. Here, these numbers are further away from 10. Even the closer ones are still 10 away, and then these guys are 20 away from 10. So this right here, this data set right here is more dispersed, right? These guys are further away from our mean than these guys are from this mean. So let's think about different ways we can measure dispersion, or how far away we are from the center on average. Now, one way, this is kind of the most simple way, is the range. And you won't see it used too often, but it's kind of a very simple way of understanding how far is the spread between the largest and the smallest number. And literally take the largest number, which is 30 in our example, and from that you subtract the smallest number. So 30 minus negative 10, which is equal to 40, which tells us that the difference between the largest and the smallest number is 40. So we have a range of 40 for this data set. Here, the range is the largest number, 12, minus the smallest number, which is 8, which is equal to 4. So here, the range is the largest number. Twelve minus the smallest number, which is 8, which is equal to 4. So here, range is actually a pretty good measure of dispersion. We say, okay, both of these guys have a mean of 10. When I look at the range, this guy has a much larger range, so that tells me this is a more dispersed set. But range is always not going to tell you the whole picture. You might have two data sets with the exact same range, where still, based on how things are bunched up, it could still have very different distributions of where the numbers lie. Now, the one that you'll see used most often is called the variance. The variance. Actually, we're going to see the standard deviation in this video. That's probably what's used most often, but it has a very close relationship to the variance. So the symbol for the variance, and we're dealing with the population variance. Once again, we're assuming that this is all of the data for our whole population, and we're not just sampling, taking a subset of the data. So the variance, its symbol is literally this sigma, this Greek letter squared. That is the symbol for variance. And we'll see that the sigma letter actually is the symbol for standard deviation, and that is for a reason. But anyway, the definition of a variance is you literally take each of these data points, find the difference between those data points and your mean, square them, and then take the average of those squares. And that sounds very complicated, but when I actually calculate it, you're going to see it's not too bad. So remember, the mean here is 10. So I take the first data point. I say let me do it over here. Let me scroll down a little bit. So I take the first data point, negative 10. From that, I'm going to subtract our mean, and I'm going to square that. So I just found the difference from that first data point to the mean and squared it. And that's essentially to make it positive. Plus the second data point, 0 minus 10 minus the mean. This is the mean. This is that 10 right there. Squared. Plus 10 minus 10 squared. That's the middle 10 right there. Plus 20 minus 10. That's 20 squared. Plus 30 minus 10 squared. So this is the squared differences between each number and the mean. This is the mean. This is the mean right there. That is the mean. I'm finding the difference between every data point and the mean, squaring them, summing them up. and then dividing by that number of data points. I'm taking the average of these numbers, of the squared distances. So when you say it kind of verbally, it sounds very complicated. But you're taking each number, how far, what's the difference between that, the mean, square it, take the average of those. So I have 1, 2, 3, 4, 5, divide by 5. So what is this going to be equal to? What is this going to be equal to? Negative 10 minus 10 is negative 20. Negative 20 squared is 400. 0 minus 10 is negative 10 squared is 100, so plus 100. 10 minus 10 squared, that's just 0 squared, which is 0. Plus 20 minus 10 is 10 here. 400. This situation, our variance is going to be 200. That's our measure of the dispersion there. And let's compare it to this data set over here. Let's compare it to the variance of this less dispersed data set. So let me scroll over a little bit. So we have some real estate. Oh, I'm running out. Maybe I can scroll up here. There you go. So let me calculate the variance of this data set. So we already know it's mean, so it's a variance here. Variance is going to be 2. That's our measure of the dispersion bit. Mean, so it's a variance squared. 12 squared minus 10 is 0, so it's equal to all. So the variance of this data set right here, we have 10 over 5. So the variance of this less dispersed data set is a lot smaller. The variance of this data set right here is only 2. So that gave you a sense. That tells you, look, this is definitely a less dispersed data set than that there. Now, the problem with the variance is you're taking these numbers, you're taking the difference between them and the mean, then you're squaring it. It kind of gives you a bit of an arbitrary number. If you're dealing with units, let's say if these are each, negative, well, let's say these are, let's say they're distances. So this is negative 10 meters, 0 meters, 10 meters, this is 8 meters, so on and so forth. Then when you square it, you get your variance in terms of meters squared. It's kind of an odd set of units. So what people like to do is talk in terms of standard deviation. Standard deviation. Standard deviation. Which is just the square root of the variance in terms of meters squared. It's kind of a distances. So this is negative 10 meters. Kind of a dispersed data set than that there. This data set right here is only 2.
Take the guilt out of your listening pleasures by indulging in what you love with Premium. Download and listen to ad-free music wherever your day takes you, so it's even easier to tune in to what you really want to hear. Get 1 month of Spotify Premium free. Tap the banner to learn more.
So that gave you a sense. That tells you, look, this is definitely a less dispersed data set than that there. Now, the problem with the variance is you're taking these numbers, you're taking the difference between deviation, which is just the square root of the variance. It's just the square root of the variance, or the square root of sigma squared. And the symbol for the standard deviation is just sigma. So now we figured out the variance. Very easy to figure out the standard deviation of both of these characters. The standard deviation of this first one up here, of this first data set, is going to be the square root of 200. Square root of 200 is what? The square root of 2 times 100 is equal to 10 square roots of 2. That's the first data set. Now, the variance of the second data set is just going to be the square root of 2. Variance is going to be the square root of that. Sorry, the standard deviation of the second data set is just going to be the square root of its variance, which is 2, which is just 2. So the second data set has 1/10 the standard deviation as this first data set. This is 10 roots of 2. This is just the root of 2. So this is 10 times the standard deviation. 10 times the standard deviation. And this hopefully will make a little bit more sense. Let's think about it. This has 10 times more the standard deviation than this. And let's remember how we calculated variance. We just took each data point, how far is it away from the mean, squared that, took the average of those. Then we took the square root, really just to make the units look nice. But the end result is we said that first data set has 10 times the standard deviation as the second data set. So let's look at the two data sets. This has 10 times the standard deviation. 10 times the standard deviation, which makes sense intuitively, right? I mean, they both have a 10 in here, but each of these guys, 9 is only 1 away from the 10, 0 is 10 away from the 10, 10 less, 8 is only 2 away, this guy's 20 away, so it's 10 times on average further away. So the standard deviation, at least in my sense, is giving a much better sense of how far away on average we are from the mean. Anyway, Hopefully you found that useful. Anna played 5 rounds of golf, and her low score was an 80. The scores of the first 4 rounds and the lowest round are shown in the following dot plot. And we see it right over here. The lowest round, she scores an 80. She also scores a 90 once, a 92 once, a 94 once, and a 96 once. It was discovered that Anna broke some rules when she scored 80. So that score, so I guess cheating didn't help her. So that score will be removed from the data set. So they removed that 80 right over there. We're just left with the scores from the other 4 rounds. How will the removal of the lowest round affect the mean and the median? So let's actually think about the median first. So the median is the middle number. So over here, when you had 5 data points, the middle data point is going to be the one that has 2 to the left and 2 to the right. So the median up here is going to be 92. The median up there is 92. And what's the median once you remove this? Now you only have 4 data points. We're trying to find the median of an even number of numbers. You look at the middle 2 numbers. So that's a 92 and a 94. And then you take the average of them. You go halfway between them to figure out the median. So the median here is going to be, let me do that a little bit clearer. The median over here is going to be halfway between 92 and 94, which is 93. So the median is 93. The median is 93. So removing the lowest data point in this case increases the median. So the median, right down here. So the median increased by a little bit. The median increases. Now what's going to happen to the mean? What's going to happen to the mean? Well, one way to think about it, without even doing any calculations, is if you remove a number that is lower than the mean, lower than the existing mean, and I haven't calculated what the existing mean is, but if you remove that, the mean is going to go up. The mean is going to go up. So hopefully that gives you some intuition. If you remove a number that's larger than the mean, your mean is going to go down because you don't have that large number anymore. If you have remove a number that's lower than the mean, well, you take that out, you don't have that small number, bringing the average down, and so the mean will go up. So let's verify it mathematically. So let's calculate the mean over here. So we're going to add 80 plus 90 plus 92 plus 94. Plus 96, those are our data points. And that gets us 2 plus 4 is 6, plus 6 is 12. And then we have 1 plus 8 is 9. And we essentially, so these are 9, and you have another 9, another 9, another 9, another 9. You essentially have, this is 5 nines right over here. So this is going to be 452. So that's the sum of the scores of these 5 rounds. And then you divide it by the number of rounds you have. So it'd be 452 divided by 5. So 452 divided by 5 is going to give us, 5 goes into, doesn't go into 4, it goes into 45 9 times. 9 times 5 is 45. You subtract, you get 0, bring down the 2. 5 goes into 2 0 times. 0 times 5 is 0 times 5 is 0. Subtract, you have 2 left over. So you can say that the mean here is 90 and 2/5. Maybe not 9 and 2/5, 90 and 2/5. So the mean is right around here. So that's the mean of these data points right over there. And if you remove it, what is the mean going to be? So here we're just going to take our 90 plus our 92 plus our 94 plus our 96, add them together. So let's see, 2 plus 4 plus 6 is 12. And you add these together, you get 37. 372 divided by 4. Because I have 4 data points now, not 5. 4 goes into 3. Let me do this in a place where you can see it. So 4 goes to 3. So you see that the median went from 92 to 93. It increased. The mean went from 90 and 2/5 to 93. So the mean increased by more than the mean. They both increased, but the mean increased by more. And it makes sense because this number was way, way below all of these over here. So you can imagine if you take this out, the mean should increase by a good amount. But let's see which of these choices are what we just described. But the mean and the median will decrease. Nope. But the mean and the median will decrease. Nope. But the mean and the median will increase. But the mean will increase by more than the median. That's exactly what happened. The mean went from 90 and 2/5, or 90.4, from 90.4 or 90 and 2/5 to 93, and then the median only increased by 1. So this is the right answer.
We all move to the beat of our playlists a little differently. And with millions of songs to discover on Spotify Premium, it's good to know you can listen without hearing ads. Just queue up your songs and get in your zone. Get 1 month of Spotify Premium free. Tap the banner to learn more.
Miguel tracked how much sleep he got for 50 consecutive days and made a histogram of the results. Which interval contains the median sleep amount? And so they're saying, is it this interval on the histogram from 6 to 6.5, or this one, or any of these? Which of these intervals contain the median? Pause this video and see if you can figure that out. All right, now let's work through this together. Let's just remind ourselves how we find the median. If I had the data points 11, 9, 7, 3, and 2, the way that we find the median is we can order it from least to greatest, or actually you could do it from greatest to least. Let's do least to greatest. So 2, 3, 7, 9, 11. And the median would be the middle number. And I have a clear middle number because I have 5 data points. If I have an even number of data points, I still would want to order them from least to greatest. So let's say that I have a 1, 1, 3, and a 7. But here, you don't have a clear middle. So the median would be the mean of the middle 2 numbers. So in this situation, Miguel has an even number of data points. So the median would be the mean of the 25th and 26th data point. These would be the middle 2 data points. So which interval here contains the 25th and the 26th data point? Well, we can start at the bottom. So we have, actually, let's just look at each interval and think about how many data points they have in it. This one has 2, this one has 9, this one has 12, and I'm just reading out how many data points there are in each of these intervals. This one has 12, this one has 11, see that there? This one has 2, and this one has 2. So if we look at just this, we have the 2 lowest. If we look at the 2 bottom intervals combined, we have the 11 lowest. If we look at the 3 bottom intervals, we have the 11 plus 12, we have the 23 lowest. So this is the 23 lowest data points. And so the 24th, 25th, 26th, the next 12 data points starting from the bottom, starting from the lowest, are going to be in this next interval here. And we care about the 25th and the 26th, so they're definitely going to be in this interval from 7.5 hours of sleep to 8 hours of sleep.
No signal? No problem. With Premium, you can open up a new world of listening possibilities. Download and play what you want to hear wherever you go offline. And with ad-free music listening, it's easier to stay in the zone without audio interruptions. Get 1 month of Premium free. Hit the banner to learn more.
You're not supposed to have it all together. You're not expected to have it all together.
Mr. Jadab raised all of his student scores on a recent exam by 10 points. What effect did this have on the mean and median of the scores? Now, there's two ways we could approach this. One is we could come up with a simple example that meets the constraints, a plausible combination of scores, and then see what was going to be true, which of these statements get contradicted or don't get contradicted. That's one technique, and that might actually be a simpler one if you're under time pressure in something like the SAT. And another technique is to do it a little bit more rigorously. So let's do the simple way first. So when you say, okay, his students, you imagine a classroom with 20 or 30 students, but they don't say it's 20 or 30 students. You can imagine that it could be, so let's do the simple way first. So when you say, okay, his students, you imagine a classroom with 20 or 30 students, but they don't say it's 20 or 30 students. You can imagine that it could be three. Do the simple way first. So when you say, okay, his students, you imagine a classroom with 20 or 30 students, but they don't say it's 20 or 30 students. You can imagine that it could be 3 students. And if it could be 3 students, then these statements need to be true for any of the plausible combinations of scores. So let's just think a simple one. Let's just imagine that the 3 students all got 80s. And I just randomly picked those numbers because it's very easy to calculate both the median and the mean here. The mean here is 80, and the middle score here is the median is also 80. So both median is equal to 80 here, and the mean is equal to 80. Now, if you added 10 to all of these, then it becomes a 90, a 90, and a 90. And then your median and mean are both going to become 90. Median is going to be equal to the mean, which is going to be equal to 90. So at least for this case, which is plausible. It's not necessarily the case that they're talking about, but for this case, when you increased by 10, but when you increased all the scores by 10, both the median and the mean increased by 10. Now let's see what these statements say. The mean increased by 10 points, but the median remained the same. The same in this case, right? Well, that was the scores of the students, but and the median is predicted, so we can't contradict this. In order for taking the SAT, mean would increase by 10 points, and the median would increase by. Move on. Now, I'm sure a lot of you probably want a little bit more of a rigorous that out as well. So it contradicts this. In order for us to be able to select a statement, we have to feel good that it would be true for any combination of scores that his students had. So we could cross that out as well. So if I'm under time pressure, I'm taking the SAT, I would definitely do this choice and then move on. Now, I'm sure a lot of you probably want a little bit more of a rigorous proof that we could say, like, for any combination of scores, the mean would increase by 10 points and the median would increase by 10 points. And for that, we could do a little bit of a justification, borderline proof right over here. So let's just imagine, this is the score 1, and then this right over here is the median score, and then we keep going, and then this is the nth. That is the nth score right over there. Now, if we added 10 to everything, the order isn't going to change. So all of these scores, these n scores, are just going to go up by 10. So this is going to be S1 plus 10, and then you're going to have S2 plus 10, and then you're going to have your former median plus 10. But that's still going to, but now this thing's going to be the middle value, and then you're going to have your highest value. I'm assuming that I ordered these from lowest to highest, and then you're going to have your highest score plus 10. So if all the scores go up by 10, whatever was the kind of that median, that's still going to be in the middle, but now it's going to be 10 higher. So your new median is going to be 10 higher. So hopefully this justification shows that for whatever combination of scores, if you order them in this way, and you need to order them to figure out the middle value, the median value, that the median indeed would go up by 10. I also feel good that the mean would go up by 10. So how would you calculate the mean? So the mean is going to be the first score plus the second score all the way to the nth score, and you're going to divide it by n. That is going to be equal to the mean. Now, if you added 10 to all of these, if it was S1 plus 10 and plus S2 plus 10, and we went all the way to Sn plus 10 divided by n, well, what's that going to be? What's that going to be? Well, if we take all the 10s out, we're adding 10 n times. So we can rewrite this as S1 plus S2 plus Sn, and then we have 10 plus 10 n times. So we can write plus 10n, and then divide that whole thing by n. I just rewrote this. Instead of adding the 10 n times, I just wrote 10 times n, or n times 10. Well, this right over here, I can instead write this like this. This is going to be that divided by n plus that divided by n. And what is this value right over here? This is your mean, or your old mean, and 10n divided by n, well, it's going to be plus 10. So your new mean is going to be the old mean plus 10. So hopefully that gives you justification, not just using a special case to rule out that contradicts these other cases, but a justification why this would be true for. We're told a store has 5 different lengths of extension cords for sale, as shown in the table above or to the left. If the range of lengths of the 5 cords is $7 feet. What is the greatest possible value of x? Pause this video and try to figure that out. Well, let's just remind ourselves what the range is. The range is going to be equal to your high value. At our high value is 7 feet. And so we get 7 is equal to x. Well, our low value is the 6 feet value of x. So let's just assume that our high value here is x. And then what's going to be our low value? Well, our low value is the 6 feet right over here. And then we know that the range is 7 feet. And so we get 7 is equal to x minus 6. You can add 6 to both sides, and you would get that x is equal to 13. That's the greatest possible value of x. We're told a store
Same plan, different moods. Give yourself and your loved one listening freedom with Spotify Premium Duo. Tune in together or make the most of time apart to recharge with your own playlists, albums, and podcasts. Tap the banner to learn more.